Welcome back, everybody. I'm Dave, and today I'm going to go through a past exam question. This one is on L'Hopital's rule. It featured in an IB higher level paper, would also feature in an AP Calc or A-level course, for example. It's 5 marks. I should be able to do this in 5 minutes or less. Okay, start the clock. Use L'Hopital's rule to determine the following. As x tends to 0. Okay, so let's have a look at what happens when we plug 0 into this immediately. Well, we have 0 on the numerator, and I can see that 5 times tan 0, tan of 0 is 0, so we have an indeterminate form. This is why they're asking us to use L'Hopital's rule in order to solve this. So we are going to differentiate each one of these things independently. So I'll start by differentiating 2x cos x squared. So we have 2x cos x squared. And to differentiate this, we'd have to call this u and v. So it's actually a product rule question. So we've got v to u. So we have cos x squared times the derivative of u, which is 2, plus u, which is 2x, times the derivative of v, which is negative sine x squared, times by the derivative of the 2x here. So that's 2x. Now, tidying that up, I would have 2 cos x squared. Now, just be careful here. So we've got a 2, an x, and a negative here, right? So this is all going to become minus 4x squared sine x squared. Okay, so that is the numerator after I've differentiated it one time. Now, remember, you may have to differentiate it twice or 3 times. We don't know yet. So let's have a look at the denominator. I'll do this in this sort of purple color here. So we've got now 5 tan. So the derivative of tan is sec squared. So we have divide. So 5 times sec squared x. Right, I don't think I need to differentiate anything again. I'll just draw a cloud around my result here. I've differentiated only one time, but that should be enough, because if I look at sec squared, remember what sec squared is. That is 1 over cos squared x. So this is actually, this denominator is actually 5 over cos squared x, right? Now, if we go ahead and look at the limit that we are substituting in, that is 0. So if I do that now, if I substitute that into the denominator here, cos of 0 is 1. So therefore, this will become 5 over 1. So this whole denominator here is going to just become 5, right? So we have something over 5. Now, let's go ahead and substitute 0 into the numerator. So I'll switch over to the laser pointer here. So we've got 2 times cos of 0. Now, cos of 0 is 1. So therefore, we have 2 times 1, subtract, let's go back here, 4 times 0. Okay, so this whole expression is going to be 0, because it doesn't matter what this is. It's all 0 because of this x. So therefore, it's just 0. There's our result, 2 over 5. Stop the clock. Let me know how you get on in the comments below. Don't forget to like and subscribe to the channel. See you next time.